15. Question number 4 on worksheet number 15 that asks us to find the tension on the rope that separates the two objects below. You guys remember what the general strategy is when we're looking for, say, a tension force? What's another name for a force that acts in between two objects like this tension force? It's an internal force, right? When we want to find an internal force, this would be like, in the story that I was telling you guys about the ice cream truck, this would be like the force that was acting on the ice cream pallet. Not anything that was acting on the outside, but something that was acting inside the back of the truck between one ice cream pallet and another, an internal force. Now, when we're looking for an internal force, what do we got to do first? There's 2 steps to this, right? The first step is to analyze the system, analyze the whole system. Don't pay any attention to the internal force. Ironically, when you're trying to find an internal force, the first thing you do is ignore all the internal forces. If we're analyzing the system, we're going to say F net here is equal to the sum of the forces. We'll call this F1, we'll call this F2, or FA and FB, whatever you want to call them. The net force here would be mass times acceleration. And what mass would I use? 25, 10, or 35? We're going to use 35 here. When you're analyzing the system, you got to use the whole mass on this side. Now, you don't know the acceleration. F1 is negative 150 because it's to the left, and F2 is positive 250 because it's to the right. So we're going to say A is equal to 100 divided by 35. 100 divided by 35 gives me, I think, 2.85714. Is that right? Why did I not round that to 2 significant figures? It's not a final answer, right? We just found the acceleration of the system. Now, what do we do next? Pick an object. Pick an object, any object. Let's pick one object. What object makes sense to pick here? Although both of them work, one of them is a little bit easier to deal with. Which one is it? Probably the what? Object number 2, the 10 kilogram object? That's what I would pick, just because it's 10 kilograms, right? And whenever we're dealing with a 10, it just seems to be easier to deal with than a 25. Although you're going to get the same answer either way. It doesn't matter, as long as you do it correctly. Let's analyze the 10. There's a force F2 to the right on the 10 of 250 newtons. There's a force to the left of Ft, and that's what we're trying to find here. So I'm going to say now F net is equal to Ft plus F2. I'm paying attention to the internal forces now, right? Because I'm trying to find an internal force. The net force is M times A. What mass do I use? 25, 10, or 35? 10. I got to use the 10. Why not the 35? Well, because I'm not analyzing the system. Analyzing the system, use the mass of the system. Analyzing object 2, use the mass of object 2. So we're going to say 10 times, how come I can use the acceleration from the system? If we keep going back to that ice cream truck analogy for a second here, the acceleration of all the ice cream inside the ice cream truck is the same as the acceleration of the ice cream truck. So even though it's internal, it doesn't change the fact that the acceleration of the whole thing outside and inside is the same rate. 10 times 2.85714 equals Ft, that's what I'm looking for, plus F2, which is to the right, which is 25 newtons, or 250 newtons, I should say. So we're going to say 10 times 2.8 is 28, 28.5714 equals Ft plus 250, and we're going to take the 250 over by subtracting, and when we do, we get 221.43. Actually, it's going to be negative 221.43, which we would expect, right? Because the way that we had it drawn on our diagram was to the left, so it's got to be a negative value. Where are we going to round that to? How many digits? 2 digits. So that's going to be negative 2 point, let's see here, 2 digits. The third digit is a 1. So that second digit is going to round down. 2.2 times 10 to the 2 newtons. 2.2 times 10 to the 2 newtons. Now, how many people, anybody picked the 25 kilogram object to analyze? What did you guys get? positive 2.2 times 10 to the 2 newtons, right? I got negative 2.2 because my tension force is to the left. You got positive 2.2 because your tension force is to the right. Are they both marked correct? Absolutely. Absolutely. It doesn't matter which one you pick. The reason that I did this now, just after we're doing Newton's third law, is to illustrate to you that, look, it doesn't matter which way you do it because the forces are always equal and opposite, right? Just an kind of an application of Newton's third law here, recognizing that those forces have to be the same. Even when one mass is clearly heavier than the other, the force is the same. Got it?